Myself, Supriyanand, Assistant Professor, Department of Electronics and Communication Engineering, RIT. We shall see the experiments on Analog and Digital System Design Laboratory, BECL305. In this video, we can observe or realize the binary to gray code conversion. In general, the binary numbers are widely used in the digital electronics, but the multiple bits may change at once, so which will cause errors in the encoders, analog to digital converters, or in some of the data transmission, which is nothing but while we are transmitting these digital data, there may be some error possibilities. So in order to resolve or in order to correct these error bits, they have invited a gray code which will resolve the error bit, and that will be easy for the data transmission. In other words, the gray code solves this by allowing only one bit change between these successive values, which will minimize the errors and improve the reliability of over the data transmission. So these gray codes are also called as reflected binary code, where the gray code is a non-weighted code with that unit distance property, meaning consecutive values differ by only one bit. We shall see an example for the conversion of binary to gray code. Here you can observe an example, and you can also observe the XOR gate truth table. In order to realize or observe the binary to gray conversion, you should know the operation of the XOR gate. The XOR gate will have the two inputs and one output, where 0 0 will reflect with 0, 1 0 will reflect with 1, 0 1 will be equal to 1, 1 1 will be equal to 0. By knowing this operation, you can convert the binary into the gray code. You can observe the binary code. Just for an example, we have taken it as 1 0 0 1 1 0. In order to convert this, you should know that the first bit is always called either this one or this one. You can observe over the screen. These we call it as the MSB. That is nothing but the most significant bit. And the other values at the end we call it as the least significant bit. Always remember, while converting from the binary value into the gray code, carry the MSB, that is the most significant bit, as it is as for the gray code. Here, the one is the binary code, that is the MSB. I am taking it as same for the gray code. Next is the second binary bit is 0. I need to make the XOR operation with the previous one, which is nothing but n minus 1. XOR with n minus 1. So n minus 1 is 1 here. This is bit 0, bit 1, bit 2, bit 3, bit 4, bit 5 for the example we have taken. Make this the XOR operation with 1. As you can already observe, 0 XOR with 1. 0 XOR with 1 reflects with 1. I am retaining the same value as 1. At the next, 0 XOR with 0. What you can observe here, 0 XOR with 0 is equal to 0. Therefore, write the output or the gray code as 0. Similarly, 0 XOR with 1 is equal to 1. I am reflecting the same here. 1 XOR with the previous bit 1 is equal to 0. So therefore carry the same. Always remember the MSB will be the same. The next bit what we are going to consider for the gray code will be XORed. And we are going to write the gray code equivalent. Here, this represents the circuit diagram. We are making use of the NOT gate, NAND gate, as well as the 74139 IC in order to realize this. We are taking the binary bits B0, B1 and B2, and the gray bits output as G0, G1 and G2. G represents the gray code, B represents the binary code. Make the circuit connection as per the circuit diagram. We are having one A, that is the two binary, that is nothing but a A and B bits what we are considering. From the pin number 1, make it as an enable and give it for the NOT gate, and once again consider it as the G2, that will be the gray code. Next, these are the input data lines for the NAND gate. Make the circuit connection as per the circuit diagram and realize the same over the gray code. We shall see the realization.
We shall verify the truth table for binary to gray conversion. This is B0, B1, B2, G0, G1, G2. For 0, 0, 0, the values are 0, 0, 0. For 0, 0, 1, the value is equal to 1. For the value 0, 1, 0, the gray code is 0, 1, 1. Similarly, for 011 the value is 010. For 100 the value is 110, and verify for all the values. For 111 the value is 100. Similarly, verify the truth table for all the values of binary to gray conversion.